Law of signs, the ambiguous case. Let's start with an example. So A is 7, B is 2, and beta is 25 degrees. So let's draw ourselves a little triangle. So if this is 7, this is alpha. If this is 2, this is 25 degrees. That makes this C and this gamma. And then draw the box. So we have A, B, C, alpha, beta, gamma. So A is going to be 7, B is going to be 2, beta is 25. Alright, so we know we're going to use law of signs because we've got that match. There's that match. So that tells us I can use law of signs. So then I can set this up and I can say, always start with what you know. So the sine of 25 degrees is to 2 as the sine of alpha, that's what I don't know, is to 7. And I picked that one to find because I knew A. You always have to have 3 things here to get started. So always set a proportion with the 2 that you know. So we're going to solve this. We're going to multiply both sides by 7. So we get the sine of alpha is 7 times the sine of 25 degrees all over 2. So here that means alpha is going to be the inverse sine of 7 times the sine of 25 degrees all over 2. When you key that in your calculator, make sure you have the correct amount of parentheses. Remember, your calculator will put that one in for you, the one I just drew in red. You have to close that and then divide by 2 and then have another parenthesis. Alright, so when you do that on your own, you might find something kind of interesting there. So I'm going to hold right there and let you do that and see what you get. Okay, and I'm going to come back to right here because you're going to ask yourself, why did I get that? So if I multiply this out, 7 times the sine of 25 degrees divided by 2, that gives me 1.47. So that tells me that this equation tells me the sine of alpha is 1.47. And what do you notice about 1.47 being the sine? Well, the sine occurs in the range -1 to 1. It's the smallest it can be is -1. The largest it can be is 1. The sine cannot be 1.47. So you got an error or something over here. Different calculators might give you different error messages. So that's why, because there is no angle whose sine is 1.47. So the conclusion in this case is that we have no triangle. This is not a triangle. A triangle does not exist here. Alright, so that's our first case. Let's do another example. And I'm going to change just one thing here. I'm going to erase some stuff so we can see how the problem is going to change when we work through these ambiguous cases here. Alright, so A is still going to be 7, and B is now going to be 12. So that's the only thing I did is I changed B. Let's go ahead and use law of signs again. So this says the sine of 25 degrees is to 12 as the sine of alpha is to 7. And when we multiply that out, we get the sine of alpha equals 7 times the sine of 25 degrees all over 12, and that actually is a number less than 1, So we're good there. So alpha is going to be the inverse sine of 7 times the sine of 25 degrees all over 12. Okay. And when you do that, you're going to get 14.27 degrees. Okay. And then I'm going to come back here and calculate this out. And when you calculate that out, you get 0.2465. So let's hold this thought just a minute here, and let me pull up a new sheet and describe to you what you need to look for. So here's our circle. Alright, so you ended up with an angle of 14.27 degrees. There it is right there. There's our 14.27 degrees. And the sine is the y value. So I could drop that perpendicular right there, but I'm going to carry it over here. So this distance right here, that's the sine value. That's 0.2, what do we say, 0.2465. Well, I've got that over here, and then due to symmetry, I've also got that over here. So there's actually another angle. Let me color code it. So this angle, again, was your 14.27. There's actually another angle all the way over here, right? That gives you the same sine value. It has the same y coordinate. So what is that angle? Let's just call it theta. Well, we know that from here all the way over here is 180 degrees. So I can take 180 degrees and I can subtract this red one here, 14.27 degrees, and then I end up with, in this case, 165 degrees. So 165 degrees gives you a sine of 0.2465. Likewise, the sine of 14.27 degrees gives you the same exact sine. So which one is it? Alright, so now we got to come back here, and in your work, after you have calculated this, you would put or 180 minus 14.27 degrees, and that turns out to be 65 degrees. Yep, I think I must have rounded that off there a little bit. Okay, but can it be 165 degrees? You already know that one angle is 25 degrees. Let's go back to our other piece of paper here a minute. So all three angles, alpha plus beta plus gamma, have to add up to 180 degrees. So you had 165, maybe, and then you already had 25, right? So when you add those up, already you're greater than 180 degrees. So we say that this is not valid. So on your work paper, you would do this, and you would kind of cross that out. And so you have just proven to yourself that this angle, 165, is not the correct angle. The correct angle for this case is the 14.27. So you would write the 14.27 degrees in your box, and then you would continue on solving for gamma and solving for C. I'm not going to do that in this example. Alright, so let's do a third case, and this case is going to be very similar, and you can maybe already guess what's going to happen, because in our first example we had no triangle. This example we ended up with one and only one triangle, and so you can probably speculate that the third example I'm going to do next, we are going to end up with two triangles, and you are absolutely right. Alright, so let's change this example slightly, and so now we're going to say that B is, I think I've got 5 here. B is 5. Okay, so let's set up our proportion. So I have the sine of 25 degrees is to 5. As the sine of alpha is to 7. I'm going to go through this a little quicker. We've already done this a couple times. So alpha is going to turn out to be the inverse sine of 7 times the sine of 25 degrees all over 5. And then when you key that in, I'm going to write that over here, you are going to end up with 36.3 degrees. 36.3 degrees. But then you have to say to yourself, wait, it could be 180 minus 36.3 degrees. And when you do that, you get 143.7 degrees. Oh, that could be valid. If I added up 25 and 143.7 degrees, alright, if I add that up, then I'm going to get a valid angle there. Okay. So now at this point, before we do that, at this point, I'll make myself a little bit more room here. Wish I had larger paper. So at this point, you have to draw a second box because you actually have two triangles. All right. So we're going to draw the second box. What's known as the ambiguous case. Ambiguous because it's more than one thing. Okay, so 7 was a given, and 25 was a given, and 5 was a given. Alright, so then in case number 1, alpha was 36.3 degrees, and in case number 2, alpha is 143.7 degrees. So we'll call this case number 1, and we'll call this case number 2. Alright, so in case number 1, you have to figure out gamma. So gamma is going to be 180 minus 36.3 degrees and minusing 25 degrees. And when you do that, you end up with 118, there we go, 118.7 degrees, and then you can solve for C on your own. In case number 2, you end up with gamma is 180 minus 143.7 degrees minus the 25 degrees, and when you do that, you get, I think, 11.3 degrees. And again, you can solve for C on your own. So, law of sines, this is the ambiguous case. You get no triangles, one triangle, or two triangles. And the way I remember this is, let me pull up my other notepad here a minute. The way I remember this is when I use inverse sine, I always think anytime I use inverse sine of an angle, I always have this condition, because I've always got some angle over here and a matching, if you will, point over here, matching with symmetry. So I have two angles here, supplementary angles, whose sine is the same thing. So I always remember to run the ambiguous case by figuring out what that other angle could be. Alright, this is the end of the example of the law of sines with the ambiguous case.